Morning to everyone and my natural from Intang, China. Today I want to present about the presentation to chapter 6 Vector and Scalar. TBM 10013 and generally made the method 1 TKM 1A. My name is Evasion. My matrix number is 01 TKM 23 F1040. My next number is Muhammad Ashari 50 Ping Roti. Their matrix number is 01 TKM 23 F1033. The third member is Muhammad Shame bin Ismail. Their matrix number is 01 TKM 23 F1002. The last member is Muhammad Rajin Anwar. Their matrix number is 01 TKM 23 F1027. Next, I want to talk about content table. The content table have introduction, example, left-right application of vector and scalar, question with solution of videos file, conclusion and reference. Then I want to talk about the introduction of scalar and vector. Scalar and vector are fundamental concepts in mathematics and physics, distinguishing quantity based on their characteristics. A scalar is a single magnitude-only quantity. Scalar is type of temperature that can be fully described by a numerical values. On the other hand, a vector is a quantity that possesses both magnitude and relation, like velocity of force, requiring not only a numerical values but also a specific orientation. Understanding the distinctions is crucial in values sensitive discipline, as it lays the foundation for an analysis and dispensing driver physical quantity. I want to present about a definition scalar and vector. Scalar is a mathematical quantity that is represented by a single left number and do not have any associated relation. In other words, it is a physical of mathematical quantity that can be completely described by this magnitude of size alone. Scalars are used to measure an of quantity properly that do not have specific relation such as mass, temperature, volume, distance, and time. Unlike vectors with have both magnitude and direction. Scalars only have magnitude and can be at such as multiple of device using regular arithmetic operations. Definition vector. A vector is a mathematical object that represents both magnitude and direction. It is used to describe quantities that have both size and specific direction in space. Vectors are commonly represented by arrows. Vectograms of the arrows represent the magnitudes of the vectors, and the direction of the arrow represents the direction of the vector. In physics and mathematics, vectors are used to describe values physics quantity such as displacement, velocity, acceleration, force, and momentum. As vector as a magnitude which represents its size of length and direction which indicate the orientation of angle of the vector in relation to a reference frame. Vector can be at success multiple and reverse using specific mathematical operations. These operations take into account both magnitude and direction of the vectors. Additionally, vectors can be decomposed into their components along different sets of directions, allowing for more detailed analysis and calculations. Scalar and vector. Scalar have mass, length, distance, speed, power, energy, work. Vector has displacement, velocity, acceleration, force, weight, friction, and momentum. Then I want to talk about the next application of vector and scalar. First, we can see about social engineering. Vectors are used to represent force acting social such as builders of buildings. For example, when analyzing builders, engineers use vectors to represent the magnitude and direction of the force exerted by a wheel of the builders, traffic loads, wind loads, and seismic force. By analyzing Test methods engineers can determine the scalar integrity and design operated support systems. Electrical engineering. Vectors are used to represent electrical quantity in power system. For instance, in three-phase power systems, vectors and theorems are represented as complex numbers which consist of a scalar magnitude and a vector phase angle. Vector analysis is used to calculate the power force analysis, force conclusion, and design efficient electrical distribution systems. Then I want to talk about field mechanics. Vectors are used to describe field force in engineering applications. For example, in designing a pipeline system, engineers use vectors to represent the velocity and direction of fluid flows. By analyzing these vectors, engineers can determine fuel source, fuel rate, and optimize the design for efficient fuel computation. I want to talk about medical engineering. Vectors are used in medical engineering to analyze force and motions. For example, when designing a medical of machines, engineers use vectors to represent force, torque, and velocity. By analyzing that vectors, engineers can determine the force exchange and different components, calculate the decreased power, and optimize the design of efficient operations. Yes, my presentation is finished. Thank you.
Real-life application vector and scalar in sport. Vectors and scalars are mathematical concepts that have practical application in various fields, including sport. In the context of sport, vectors and scalar can be used to describe and analyze different aspects of the game. First, vector quantities. Vectors have both magnitude and direction. In sport, vector quantities are commonly used to describe physical quantities that have both size and direction. Here are a few examples. Velocity. Velocity is a vector quantity that describes the speed and direction of an object motion. In sports, velocity can be used to analyze the speed and direction of a player running, swimming, or cycling. Force. Force is a vector quantity that describes the push or pull on an object. In sport, force is crucial for activities like throwing, kicking, or hitting a ball. Understanding the direction and magnitude of the force can help improve technique and performance. Displacement. Displacement is a vector quantity that describes the change in position of an object. In sports, displacement can be used to analyze the movement of players in a field or track, helping coach and athletes understand positioning and strategy.
Hi, today I will explain question number 2 in review 5. We can see in the paragraph there is have arrow pointing up and arrow pointing down. The arrow pointing up is PQ while the arrow pointing down is RS. Okay, let's go to the set question. A. Express each of these vector in xi minus yj form. It want the coordinate of the two around. Let's look back at paragraph 2. First, we have to create two lines to make it a triangle. Then we read, example, from point to new point, and we will get PQ equal 6i plus 6j. Same as RS, turn it into a triangle and we will get 4i minus 3j. Next question. B. Determine the value of RS minus PQ. First, we look for RS and PQ first. Enter the vector formula which is negative OR plus OS and enter the coordinate P, O and Q. Example, 2i plus 5j plus 6i plus 2j. Result, we get 14i minus 3j. For PQ, it also the same. Enter the coordinate like 14i plus 2j plus 2i plus 8j. Result, we get 6i plus 6j. Go to the final answer, RS minus PQ. Take back answer before 40i minus 3j minus 6i plus 6j equal to I minus 9j. Last question. Calculate the unit vector of RS. We must find magnitude of RS first. Formula magnitude is square root 4 power 2 plus 0 power 2 plus negative 3 power 2 and then we get 5. After we get 5, find unit vector RS. Example, 4i minus 3j. Divide 5. For this, we must divide the fraction into 2. That is 4 divided 5 I minus 3 divide 5j and final answer is 0.8 I minus 0.6j.
Conclusion. Vector is very important in our daily life and in an engineering. So we know that vector are used in engineering mechanics to represent quantities that have both magnitude and direction. Many engineering quantities such as force, displacement, velocity and acceleration will need to be represented as vector for analysis. In this topic, we have learned the basic operation vector and scalar quantities, including their use in solving problems. We also learned the method for determining angle between two vectors and the characteristic of triple vector, also scalar product. That's all from us.